Hi everyone, welcome back. Today we want to conquer Boolean logic. Let's dive straight in. So one of the things we want to do is understand how Boolean logic is represented using circuits, and we want to understand what logic gates are. We want to look at Boolean equations. We want to look at the use of truth tables and how using different inputs will impact the output from our circuits and the order of operations. So the CPU is made up of transistors that take inputs. These transistors, also known as logic gates, are used to make decisions based on inputs that we feed into a computer. Problems can be defined using Boolean logic in Boolean equations, and Boolean equations equate to either true or false, or 0 and 1, which is what we use to get the computer to make decisions. The basic logic gates of AND, OR, or NOT help us make logical decisions. An example may be that we need to decide whether we should take an umbrella when leaving the house. So a truth table helps us visualize in which scenarios an outcome is true or false. Truth tables are a way to show every possible permutation of inputs and their results. The first one we're looking at here is an AND gate. So the AND gate stipulates that both inputs must be true for the output to also be true. The OR gate, if either or both inputs are true, then the output should be true. The NOT gate reverses the input, so 0 would equal 1 and 1 would equal 0. So lastly, the exclusive OR will only have an output of true if either A or B is true, but not both. So earlier we discussed that we can use logic to determine how a computer will produce an output based on the inputs that we give it. So imagine this scenario here, where on a Friday, a cinema might offer senior citizens discounted tickets based on their age, the date, and the time of day. So if a cashier was to deal with a particular customer, and that customer is a member, if all conditions are met, then a customer should be given a discount. So we can produce that using logic circuitry like this, and as an equation it would look like this. So this would mean that both the user's age, which is represented by A, the day represented by D, both have to be true, and if the time of day is also true alongside those conditions, then the output should be true, that the user gets a discount. So this is a logic diagram and equation. Let's create a truth table to visualize the outputs that would occur based on the possible inputs. So what I often do is I also label the outputs of each gate so that when I do a truth table, it makes it a bit clearer what each column is for. So as you can see, I've got my inputs here, A, B, and C, and these inputs count up in binary values. So because we've got 3 inputs, we count up in binary values of 3 digits. So 0, 1, 2, 3, 4, 5, up to 7. So there's 8 possible inputs. And like I said, what I normally do is I normally write the output and I give them labels. So this is my E. This is not something that's necessary. And then I might say that the result of D and E is F, and then the final result is what would be our Q. So if we were to look here then, not A, which is in my table here D, not A would be the opposite of what A is, so that should be 1, 1, 1, 1. So I'm looking at this column here, and so the opposite of the 1s here should be 0s. Next, the next column looks at the opposite of B, so the opposite of B in this case would be 1, 1, 0, 0, 1, 1, 0, 0. And now we're looking at this section. Okay, so something to consider is the order of operations. So when we look at our logic circuits and our logic equations, we have to decide what the precedence is, what must go first when we're working out what an equation looks like. So let's say I was to have an equation like A and not B or C. In this case, because a not goes first, the first thing we're going to do is we're going to work out that the not B input must be switched, must be inverted. There's no need to put brackets around that. Next, because the AND bands closer than the OR, then what we'd do is we'd put brackets around the A and not B, and that would leave us with OR C outside of the brackets, okay? And the reason why we do this is because at school you've probably been taught about BIDMAS or BODMAS, and I want you to consider the AND like multiplication and the OR like addition. So it has to go in that order of events, okay? So if you were to see an equation like the line before, then you just have to know that the AND bands closer together, so we put them in brackets. Right, so I've got two equations for you here, and what I'd like you to do is take the two logic equations one by one, and first of all, draw a logic diagram for each one, a logic circuit, and then afterwards do a truth table. Pause the video. Once you've done with that, unpause, and we're going to walk through both together. So this is the first one, which is Q equals A or B or B and C. So let's first add our inputs. So we're going to add A, B, and C. And we'll say the first one was an OR gate. So let's have an OR here. And then we had an AND gate, which was B and C. So we'll do that here. And you can see the important thing here is when I'm drawing the AND gates, my drawing is not special, and my handwriting probably isn't great, but I've got a flat line for the AND gate, which helps to differentiate. And we said that these two inputs were A and B, and this one was C, and what we'll do is we'll take a connection from B into our AND gate there, and these two both feed into an OR gate. Which results in Q. So now that we have our logic circuit, let's put that into a truth table. So just like before, you don't have to do this. I just do it for clarity to make things easier for myself. You may do this in the exam, you may not. So I'm labeling the output of the OR gate as D, and the output of our first AND gate here as E, and then obviously the output of the resulting OR gate here is our Q. So for me, the result of A or B is going to look at these two columns here, and if either are true, then the result should be true as well. So this should be a 0, 0 and 0 is 0, 0 and 1 is 1. There's 1 true, 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 and here both the inputs are true. So that should result like that. And now if we look at the next column, the next column is the result of B and C. So both of this column here and this column have to be true. So that's not true, that's not true, that's not true. This one is. Right. And then our resulting OR gate here would be if either of these two columns here are true. So 0, 0, 1, 1, 1, 1, 1, 1. That's our logic gate. Sorry, that's our truth table. Done. Okay, let's take a look at the next one. So the next one says Q equals not A and not B or C. So we spoke about the order of precedence. Obviously, we have an AND gate here followed by an OR. So we just need to understand that we need to put brackets around these two here. So let's start by adding our AND gate first, or let's do our inputs first. A, B, C, and then we'll have our AND gate for our not A and our not B, and then we have the result of that feeds into an OR gate, which takes C as an input also. That results as Q. Okay. So just like before, now that we've done our logic diagram, our logic circuit, now let's fill out our truth table. And just like before, I'm going to, for ease, I'm going to label the output of A and B as D, and the output, the final output, I don't have to label because it's already Q. Cool. So, right. So not A, I'm just going to go down this column here, and I'm going to label everything opposite, opposite of what A is. And this is obviously the opposite of B. And next, the D column will be the result of these two columns, and so that is 1, 1, 0, 0, 0, 0, 0, 0. And the result then looks at these two columns, and that's an OR gate. So if either are true, then the output is true. And that's our truth table completed for this logic circuit. Okay guys, so for the rest of the tasks that I have on these slides, I'm going to set them for you, and I'm probably going to put the answers as I do on the website. I don't think there's any benefit in me walking through the rest. I think these are good practice for yourselves. So there's task 2, there's another one. I've got quite a few tasks, and on the last slide I've got some exam style questions for you here, even though this one is a little ridiculous. It's just for fun. So question 2 here seems to have 5 inputs. In an A-level exam, an OCR A-level exam, you'll never get more than 3 inputs. I don't think you would. Right, so have fun, and I hope to see you in the next video when we go into a bit more depth.